Those of you at home, they copied this slide. So pause the video and copy it as well, please. On Friday, we took a look at what's called orbital notation. And you found out that by drawing lines and arrows and stuff like that, that you can find out a bunch of stuff about the electrons of an element using that notation. You could find out their energy level. You could find out the shape of the cloud they're spinning in just by looking at numbers, letters, and that configuration. What I want to show you today are two other notations that show the exact same thing. The reason that these other two notations are important to show you is because they're actually shorter to write. They become more and more abbreviated, and that's a good deal for you, especially in addition to that, these two notations are the ones that we use more often in AP, so it makes sense for you to know them. The only shortcoming of these is that you can't really see Hund's rule. If you remember, Hund's rule was the one where when there's multiple orbitals, you would go up, up, up before you started putting or spinning them down. You'll notice in the notations I'm about to show you that you can't see that as clearly, which would be the shortcoming of these abbreviated versions. But anyway, I want to show you how this works. So on your periodic table, I want you to take a look at phosphorus. How many electrons does phosphorus have? 50. All right. So if you were doing orbital notation, you would draw 15 arrows, right? But we are not drawing arrows today. The first notation we're going to look at is what's called electron configuration notation. But it starts the same. We know that we always start at 1s, right? Lowest energy level, simplest shape. But we're not going to draw lines and arrows in this new notation. Instead, we're going to simplify it and just put an exponent that symbolizes the number of arrows that you would have drawn. How many arrows fit in S? 2, right? Because the real question is usually how many orbitals fit in an S? 1, how many electrons does Pauli say fit in an orbital? 2, so a total of 2. And there it is. There's the whole difference. 1s2 instead of lines and arrows. What always comes after 1s? You have your famous cheat in front of you, of course. What always comes after 1s? 2s. How many orbitals fit in an s? 1. How many electrons fit in that one orbital? 2. For 2s, 2. What always comes after 2s? 2p. Now, look here for a moment. Stop doing what you're doing. There's a secondary way to think about this. If you don't want to ask yourself, oh, how many orbitals fit in a p from your notes on Friday, which is 3, and how many electrons fit total in those orbitals, it would be 2, 4, 6. Here's something that some of you have probably already realized. Take a look at the 2p block. Look at the 2p block. Have you realized that every time you add an electron, it just moves up a square? That's all it really is, right? I mean, really, it's every time you add a proton. But we know that the protons and the electrons equal each other for right now. In other words, the number of squares also matches the exponent. How many squares are there in 2p? There's 6, which is also the maximum number that you can have. So I don't want you to disconnect the fact that there's orbitals and electrons in orbitals, but counting squares is easier. What always comes after 2p? 3s. And how many squares are there in 3s? There's 2 squares. 1 orbital, 2 electrons. What comes after 3s? 3p. Now, here's where we could have cheated before we started, right? it's good to know where the finish line is. Do you see how phosphorus is in the 3p block? You can verify. So we know that 3p was always where we were going to end for phosphorus. Of the 6 squares, phosphorus is number 3. This is the electron configuration notation of phosphorus. And you can see that it's a little bit less work than the orbital notation is, because you're not doing dumb lines and arrows. You can check your work by adding up the exponents. The exponents are the arrows. So 2 and 2 is 4, and 6 is 10, and 2 is 12, and 3 is 15. So it's a good habit if you are second guessing yourself. All right. Now I'm going to have you do one, but not only are you going to do one, when I draw the card, I'm going to have one of you come up to the whiteboard. That sounds fun. All right. You don't have to be on camera if you don't want to be. I can turn it away because we will get your permission for such things. But yeah, someone's going to come up to the whiteboard. So do the electron configuration notation for yttrium. Do yttrium. Don't you have a whole thing of note cards with all the symbols? Yeah, no, but it's in your brain. It's in your brain. What is the symbol for yttrium? It's Y. Goal post. I'm sorry? Count the squares. Or think about how many orbitals a D has and then double that number. It's in your notes, man. It's in your notes.
I already had it.
No, but your constant need for verification is something that I want to break you apart from. You do. So for this notation, this is one of the very rare times in chemistry that we don't just have a lack of a number to represent. Good question. If you're the person that gets chosen to come show off your handwriting, first off, my handwriting's not pretty, so don't be embarrassed of your handwriting. But don't write too small. Sometimes y'all get up here and you go all Mickey Mouse on me. Try to match my approximate size. Also, before yttrium is done, do I need to erase my phosphorus? No, right? Because we know that the road is always the same. Yttrium has more electrons than phosphorus did. So really, I am going to erase this 3 because we'll be filling up the 3p block. But whoever comes up here, you can pick your favorite color and start by fixing my 3p. Are you ready? Let's see who it is. Aspen's out there. Let's go over to cluster 2. Ooh, it's a full cluster. Y'all feeling good? Cluster 2, seat 5. 2-5. You can bring your stuff with you. Would you like me to turn the camera? Gotcha. Hi, everybody. What do you think? All right. Yeah, all of the formatting looks good. I'm just gonna swing the exponents to the outside, just because it makes it the most correct. But it's the exact same order as the orbital notation, but no arrows. If you add up all of the exponents together, you will get 39. What's happening? Are y'all excited? Sorry, this is going to be annoying because now you're going to be on a break. But hello. Yes, it is. How are you?
You got phone number? Oh, no.
I was about to say something.
Oh my God.
That is so.
Yes, yes, you do.
No, who's Timo?
This smells horrible.
Really?
Ew.
That was only one.
Okay, make mac and cheese like the best mac and cheese ever. Make mac and cheese. Ag? Are you an ag?
How was your mac and cheese? You didn't like it?
But that's positive. Yeah, but that's positive.
Oh, that's damage right there.
You have to watch ads. That's
I love it. It's nice. That's what I
It's
get.
like a one note. That's like the exact same thing.
I don't know if that's
Just a-
I'd say
It looks like you just put a text mark. I don't know, is that a wool? Is that wood?
It's huge, huh?
Yeah, but it's made out of wool. A wool. Jeez. Oh my God.
No.
How do you understand? I can understand it, like.
That's Minecraft. I have all the give me like, no, give me like a couple months. I have a random talk. I received my okay, actually, nobody's like,
No, I didn't see that.
Like, look at
like, the quiz. Not today.
Yeah, that's what I looked at.
Only Electron.
No, that's 6.
Cool. Correct. That's how many more. How many more?
Nothing from October is in here.
Okay.
Hey, we've done like 3 assignments since October.
No, I lost. That's it.
Last Friday, it was last Friday.
How many Electron?
I didn't see that right side. If I saw that, I would have won.
That's not.
How many Electrons?
He is putting them in, but they're not doing anything to my.
Hold on.
No, they're like, oh, do triple. He's not doing anything to my game. That's 0. That's
Hold on. I gotta play him. Yeah, no, that's what I'm saying. Like what? I've been sent that. Oh, I'm going to add you. Huh? I'm going to add you.
it's just.
So easy. Why is that?
I think I
Your
do
class
something.
is literally easy.
This class is not easy.
Aren't you talking in class? What do you take? Wait, let me see. Didn't you do an essay? I'm an AP Euro. Never mind.
He doesn't play great.
Damn, you're writing bad.
Wow, that's so.
No. Featherstone. No card is popping up.
It's
gonna take a while. Nothing. I'm not even on school Wi-Fi.
That's why. Connect to the Wi-Fi and then turn on the VPN.
I bet.
That's right. It's just battle against the third.
Really? Oh my god. Don't play something.
No. What element is that? Getting dominated, bro.
Connect to the BYOD.
Alright, I'm connecting.
Isn't cello really like
I was on the guest list.
bass cello?
Featherstone.
Yeah.
Oh, it's giving me my cards. Okay. Alright. It's not bad. Not bad day. Oh my god.
Come on, I'm not gonna lie, I have no damage to it. All my cards are defensible.
It gave me some good cards, I'm not gonna lie.
There's so many farm cards.
Yeah, this is what it gave me.
Oh, no.
Cards are so weird.
Oh no.
What is this book?
I know.
I don't even know how to think. It was like grassroots of
What's
wizards.
that?
He has a weird
Huh?
ass thing. I have no cards.
Let me see.
He sucks. I just know how many damage.
Let me see it. The title.
Bro,
No hits.
I have 3 spells.
Okay, I'm so sorry. Hi, everybody. I'm back. It's me. The conversation went well because I know that's what you're really worried about. Okay. How am I doing on time? Oh, we're gonna kill it. All right. Finally, one brand new notation, and this is going to be your favorite notation of the bunch, is what's called noble gas notation. It is our super abbreviated version. But in order for me to introduce you to noble gas notation, I have to introduce you to a new family on the periodic table. So, I don't want to take you with me. Hang on one second again. All right, so if you look over here, check out my green friends over here in that final column. You see my green buddies over there? All right, now I know there's other green friends, but I'm only looking at this final column. Helium through radon, they're called the noble gases. Now you put them in brackets here. So you've got them. For those of y'all at home, all I did is I pointed to my friends way here at the end, helium down through radon, from the opening slide. Those are the noble gases. You don't really have to memorize them because they're in such an easily identifiable place on the table. But here's what noble gas notation allows us to do. We get to ignore off-ball. Do you remember off-ball? He was the dude that said, no matter what, you always start at 1s. If you go noble gas notation, or I ask you to do noble gas notation, you very luckily get to ignore that. And instead, start at the closest noble gas. Now, I always lose students here on what to do. So I want you to look very closely at yttrium's position. Look at yttrium's position, or you can look on your own. All right? Just like your slide says, in order to pick a noble gas to start at, you're going to start where yttrium is and go to the row above him. The row above him, that's scandium right above him. What noble gas is in the row above yttrium? Krypton. And that's how you pick. So krypton then is going to be the noble gas in brackets. And then we start from there. Now, if you're like, well, where's there? What is the number and letter, the energy level and sublevel of krypton? What is the energy and sublevel of krypton? He's 4p, verified. Do you see how krypton square, not only is krypton square 4p, he is 4p6. He's the 6th element in the 4p block, right? So by putting krypton in brackets, don't do what I'm about to do, but it allows you to ignore all of that. You are starting at 4p6, and what comes after 4p6? 5s2. Followed by 4d1, and you are done. In purple is the noble gas notation of yttrium. And there should be obvious reasons why this is your new favorite notation, right? Now again, I mentioned that I lose students on this every year for some reason. So here's another little important thing in case you're fuzzy. What sublevel, listen to my question, what sublevel always comes after the brackets? S, because when I say sublevel, I'm talking about a letter, right? It's always an S that comes after brackets because it's always an S that comes after a noble gas. Some of y'all get all crazy with noble gas notation. You're like, brackets, P, right? Don't do that. You have to account for everything after the brackets. So let's have fun one more time and pick another student to come up to my whiteboard. I want you to draw the noble gas notation for radium. Radium is element Ra. The noble gas notation for radium. What's up? You weren't here or you lost it? I guess it's my fault. I left the room for
You're not done.
I'll tell you the story sometime. It's a good story.
We don't have these 7. I got one more. Got one more. Suburb.
I got the 62.
Just wherever it stops at.
All right, we're gonna see a new person up here. Well, I'll see them, you might see them. Let's go get some help from cluster 3, or 3. Hi, cluster 3, you're a full cluster. Cluster 3, seats 4. 3, 4? Yeah? Would you like me to turn the camera or leave the camera where it is? It's fine. You can bring all the stuff with you that you want. And pick your favorite color. You're going to be famous forever now. I'm going to monetize this video and then I have to pay you, I guess. So much attention to that, you wouldn't even know. Sorry.
Hey, look at Ricardo.
What? He's tattling me.
For what?
Because I was about to beat him with this stick because he was on his phone. And now I have to beat you.
I eat those.
Oh, here you did. I'm not supposed to brother. Check out so radon is that for square. I'll take the Agree or disagree? All right, yeah, so we need brackets. The brackets are important. All right. But yeah, we've got radon followed by 7s2, and that's it. Hey, if I had asked you to do the orbital notation, how many arrows would you have had to draw? 88. That would be 88 arrows. That would suck, right? Now, speaking of the 88, though, there's still a way to check your work. If you like to make sure that you didn't do anything weird, all right, we know that radium is what we're configuring there. I know that radon is sitting over there with 86 electrons, and then of course this 2 right here represents the other 2 electrons, and 86 and 2 equals 88. 11, which is of course radium's electron count. So you can use that to verify your work. Y'all have a good day.